So how many pairs of people did we get? We had 5 people and we want to pair them up. How many different ways can we pair them up? So I don't have 5 people laying around for me to be able to pair them up. So I'm going to make some generic people, which I'm going to call A, B, C, D, and E. And I got very creative with their names. That's right. On this guy's birth certificate, it's just A. No last name. It's just A. He gets made fun of mercilessly at school for sure. Anyway, so let's start pairing up Mr. or Mrs. A with all of the other people in this list. I'm going to first pair them with B, and then A gets paired up with C, with D, and then finally with E. And now we're done with A. We're not going to pair up A with anybody ever again. We're going to move on with B. Well, why don't I pair up B with A? The reason why is because I already did right here, and the order doesn't matter. If order mattered, I wouldn't be finding a combination, I'd be finding a permutation. If you have taken statistics or you plan to take statistics, then you will talk about permutations together with combinations. Often permutation is the same kind of thing that we're talking about here, but the order would be important. We didn't care about the order, so I'm going to get rid of this guy. And instead, only pair up B with C, with D, and with E. And now we're done with B's forever. We're going to move on with C. C is going to be paired up with D and with E. And now C's are done. Finally, D gets paired up with E. And E gets paired up with nobody except for E did. E got paired up with all of these folks. So how many pairs do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9... We have 10 pairs. And here is the way that we often write this combination in terms of some sort of notation. So we use the letter C for combination, and outside here we put how many people we're actually talking about, how many things are in our group. And over here on the right-hand side and down below, we say how many ways are we trying to pair those things up or group those things. And for us, it was 2 of them. So sometimes we read this as 5 choose 2. All right. And we just discovered that that's equal to 10. And there's a formula for getting that 10, and it's right here in that binomial theorem. It is n factorial over n minus r factorial times r factorial. And the n and the r are the 2 numbers that we were just talking about that surround our C. So here's our n is 5, and our 2 here is our r. Okay, got it? So let's use this little formula so we can see how this thing is actually working here. It's supposed to be n factorial, that's going to be our 5 factorial, over n minus r, that's 5 minus 2 factorial, and then times r factorial, which is 2 factorial. Well, what the heck is a factorial? It means the product of all the numbers, that number, and then all the integers that come before it. Well, to 1. It's 5 times 4 times 3 times 2 times 1. Okay, so I know 5 minus 3, I'm pretty sure is 3, so 3 factorial. And 3 factorial can be written as 3 times 2 times 1. And notice that we share some common factors which can be canceled out. These 3, this 2, and this 1 can cancel out with this 3, this 2, and this 1. So far, we have 5 times 4, which I'm not going to multiply, over 2 factorial, which is 2 times 1. And, this 2 can cancel out with this 4, leaving behind a factor of 2 for a total of, you guessed it, 10. Okay, fantastic. So another thing about these little combinations, we had 5 people that we were trying to just pair up, but we could have done this. 5 people, and we could have chosen 0. 5 people, we could have chosen 1. 5 people, we did choose 2. 5 choose 3. 5 choose 4. And then finally 5 choose 5. Well, let's think about this for just a second. Let's say that we have 5 people. How many different ways can we choose none of them? One way to do it. Okay, how about this one? if I have 5 people, how many ways are there to choose one of them? Well, that's right up here. I can choose this guy, this guy, this guy, this guy, or this guy. There's 5 ways to do it. We were just able to show that if we have 5 people, there's exactly 10 ways to pair them up. That one was 10. What about these other ones? I don't want to actually have to figure out all of these other ones. I'm going to use a calculator. So most calculators have a scientific calculator, a graphing calculator has a combination calculator built into it, or a combination function. And it is under functions on this one. This is the Desmos one. On the TI calculator, it might be under the stat menu, might be under the math menu. I don't know, you might have to search for it. Okay, so function, and then it's right down here at the bottom. The lower left one, this NPR, that means permutations, which is not what we want. We want the one right next to it, NCR, those are combinations. And I think the way that this is formatted tells me here that I put in the numbers inside parentheses here. It needs 2 arguments. First one is your n value. So let me come back over here to main, and I'm going to put in 5 and then comma. I already did the 2. Let's do the 3, comma 3, and hit enter, and it's a 10. Okay. All right, how about 4? Grouping them up in sets of 4. Let's see what that says here. So I'm going to do that one more time here. By one more, I mean 2 more, because I've got one more to do after this one. And a 5 and a comma and a 4. There's 5 ways to do it? Well, let's go ahead and do that 5th one. Let's see. Go back here to functions, and we're going to... Whoa, clear that out. Come on. All right, let's put in 5, comma 5. And, oh, look, I get a 1. All right, so here, let me put these numbers down here. This one was a 5, and this one is a wait a minute, these numbers look familiar. 1, 5, 10, 10, 5, 1. Here, let's take a look here. Back here at Pascal's triangle, there are those numbers. 1, 5, 10, 10, 5, 1. Right? So if you have talked about binomial theorem in another class, it's usually tied to Pascal's triangle. And in order to find, let's say, for example, like the 70 here, instead of having to find all the numbers up above it, we can just use a combination calculator, combination function, in order to find an individual number. That's exactly what we're going to do when we go to prove the derivative rule for power functions.